Hello, welcome to Physiological Factors screencast. Today's topic is going to having a look at the physiological adaptations to strength training. Now, previously in this scheme or part of the specification, we've had a look at training types. So we've had a look at free weight training, multi-gym training, we've had a look at plyometrics, we've had a look at circuit training. We've also had a look at the resistance guidelines by which you need to work in order to improve different types of strength, whether it's maximal strength, explosive strength, or strength endurance. Now, I'm sure you're aware, people do weight training, whether it's athletes or even in kind of society. People do weight training, no matter what type it is, in order to make changes to their body. Now, academically, this is referred to as physiological adaptations. Okay, so physiological adaptations, adaptation is change to taking part in strength training. So what happens to your body? And basically, we have to have a look at kind of three key areas. You need to have a look at kind of the neural adaptations, we need to have a look at metabolic adaptations, we need to have a look at muscular adaptations. So we'll start off then with the neural adaptations. Now, your body basically undergoes physiological change if you take part in strength training, whatever it might be. And if it is a neural example, what that means is the brain is responsible for sending messages and impulses that cause adaptations within your neuromuscular system. Brain, muscle, neuromuscular. Okay, so for example, if you remember when we had a look at motor units, okay, we had a look at an impulse coming from the brain via the central nervous system, and then we had a look at it going down here into the cell body, into the axon, into the kind of motor envelope, and going down here into the muscle fibers and allowing us to contract. So that was an example of when we had that. Remember the MANSAs or acronym we use for that. So that impulse coming from the central nervous system of the brain into the motor neuron, and from there down into the muscle fibers. So the first adaptation neurally, okay, that takes place as a result of strength training is that there is an increased recruitment and synchronization of fast glycolytic type 2B motor units. Okay, and because of that, there is an increased force of contraction. Now, for people who aren't quite sure what these two things mean, okay, we know what motor unit is. We've had a look at that in quite some detail. What does this mean? What it means then, if you do lots of strength training, it means that you recruit more fast twitch glycolytic 2B fibers. So what that particularly means is your brain switches on the motor units that are required for explosive, forceful contractions. So that is the first one. So you switch more on, your brain switches them on and recruits them. And that is why people notice strength increases pretty early on, but you don't always notice hypertrophy or that your muscles getting bigger, but you notice the strength increases because you recruit more. And if you recruit more, that means that they start to synchronize. If you imagine a synchronized swimmer, it means to synchronize swimmer, you have to all work in time. And if you recruit more of them are recruited closer together, you get an increased synchronization, coordination, ability to work together to give an increased force of contraction. So you can imagine that taking place inside your bicep brachii, for example, if you did bicep curls. So there's an example of your first neural. So your brain sends an impulse to your motor unit, and that is what happens as a result, leading to an increased force of contraction. You can lift more weight. Next one. The next neural one, adaptation, basically refers to something called a decreased inhibition of the stretch reflex. Okay, so just start, don't worry about writing this down yet. Listen to what I'm saying first before I go down to that next bit. What that means is if you don't do weight training, okay, what happens is you have an inhibited stretch reflex. Remember we talking about that with plyometrics? You have a eccentric into concentric contraction. Okay, now if you don't do any weight training, your stretch reflex doesn't work. Or in other words, it's inhibited. If you take part in strength training, there is a decreased inhibition of that stretch reflex. So the stretch reflex now works. So putting that into kind of terminology that kind of we might understand from earlier in the course, what happens is the antagonist muscle becomes more active and starts to stretch before allowing the kind of eccentric, before allowing the kind of agonist to contract with more force. Okay, what does that mean? Well, I look at it and think, you watch someone in the gym for the first time, okay, they try and do a bicep curl and they're swinging back and forth. There's no stretch reflex. There's no reflex at their elbow to come back up. But after a period of 6, 8, 12 weeks of weight training, you suddenly start to inhibit reduce the inhibition of the stretch reflex. And what happens is the tricep brachii acts as a recoil, a spring for the bicep brachii to contract concentrically as the agonist in a bicep curl. Okay, so see if you get that right. We'll have a look through it in lesson. So that is the next one. What would you get in the mark scheme? This here is what would be in the mark scheme. This bit down here is for understanding, to try and get it into your brain. So that would be what would be required for your mark scheme for your answers in an exam if a question like this came up. Okay, let's have a look on your next lot then. So from there then, that's neural. These involve brains sending impulses, and of course this comes from the brain to inhibit this. So next one is metabolic. Now, we're talking about metabolic. We are talking about fuels that can be broken down via heat, energy, or to provide energy, and you will start to think now, so fuels that can be broken down. So if I said to you now, if we look back at kind of, I suppose, the previous study so far, we've looked at certain fuels that are, I suppose, really important for energy systems, such as the ATP-PC system and also for the glycolytic system. So what happens if you take part in a kind of prolonged weight training is you actually increase the amount of fuel stored in your muscles to allow kind of forceful contractions. So let's have a look then. First thing then, the adaptation, there is an increase in the amount of ATP, PC, and glycogen stored in your muscles. Okay, so that happens naturally after strength training. Okay, now just having these fuels on their own will not allow you to provide, to give you anaerobic energy. We know that. So if you have a fuel, an increase in fuel source, it's useless unless you have an increase in these kind of protein catalysts that break it down. Okay, do you remember what they are? So what you have then, as well as having an increase in ATP, PC, and glycogen stores, you also have an increase in anaerobic enzyme activity. So what we're looking at here then, so an increased anaerobic enzyme, we're looking at the enzymes that break these down. So ATPase, creatine kinase, GPP. They are more likely to break down if you do weight training. They are more apparent, they're more evident, they're more kind of useful for the stores that you've got in your muscles. So the net effect of this is just to say that this leads to an increased anaerobic energy production. So when we're doing things like shot put, when we're doing things like javelin, when we're doing things like 1 rep max. So there's neural, there's metabolic. Finally, we have the one that I'm assuming people would find a little bit more, in real life, that you would use in daily life, as we look at this, muscular. The muscular changes that happen as a result of strength training are as follows. There is an increased muscle hypertrophy, okay? So there's increased hypertrophy, which refers to an increase in size, a fast twitch, glycolytic, or oxidative 2A and 2B fibers. Maybe just put fast 2A, 2B fibers. Okay, they increase in size. Now, because of that, well, alongside that, there's another thing that happens that you won't have heard of, I don't think. And this is called an increase in muscle hyperplasia. Now, hyperplasia basically refers to the 2A, 2B fibers splitting. Okay, so they split, and this then causes the muscle to increase its cross-sectional area, as we looked at in the factors affecting. And that then, if you get this and this, an increase in hypertrophy and an increase in hyperplasia, they kind of work together, but you get separate credits in the exam for these. This will then lead to an increased force of contraction. So anything on the right side is the effect that it would allow. And finally, there is one other muscular adaptation, and this basically refers to lactic acid. And if you take part in lots of strength training, imagine the first time you do a weight training, you might do a few reps and you start to get a burn in your muscle. That's lactic acid. If you do lots of strength training, I suppose, bring on an effect that is really, really helpful with regard to lactic acid removal. And it's called the buffering capacity. So the increased ability to buffer, move away lactic acid. So what we're looking here then, what does that mean? It basically, if you're going to describe that, there is an increased tolerance to lactic acid. Okay, so if you have an increased tolerance to lactic acid, what does that mean? Well, it means that you can work without oxygen for longer. And if you're going to sum that up, it means that you have an increased anaerobic threshold. Now, all of these are adaptations. There is 1, 2, 3, 4, 5, 6, 7 adaptations that take place as a result, and they're categorized by being neural, metabolic, and muscular. It's worth just making sure you put this here first: neural, brain, metabolic, fuels, and then muscular, actual skeletal muscle, and what happens to that. So just get those in there, make sure they're categorized, and in lesson we'll have a look at ways to remember it and application to previous work. Okay, thanks very much.